Somebody said open sentence, and did I start recording that? Somebody said open sentence, and that was not correct. Open sentence is an equation with at least one variable. That's an open sentence, okay? All right, evaluate each expression. So let's walk through this first one. Bokar, go ahead. It's going to be, A is -4. Can you see the negative sign? So when we replace A, we get -4 plus 5. So what's that going to be? Nice. So you see different signs, you take the difference and you subtract, and what's that going to be? The magnitude is going to be what? 1. And you chose positive because why? Right. 5 is a larger magnitude than 4, so we're going to make that a positive 1. Keep the sign of the larger magnitude 5, so it's positive 1. Very good. This next problem threw a lot of people off. Can I get a volunteer to explain this one? Go ahead, Kimberly.
So you would replace A with -4.
Right. And so can you read to me what you got when you replaced A?
So that would be 9 minus -.
Okay, this is where a lot of people made mistakes. They would just put 9 minus 4. Okay, that was one mistake that's really common. I saw that even in high school quite a bit. Okay, and then the next mistake I see pretty frequently. Let's see if you caught this part.
Then after that, when there's 2 signs in front of the 4, so then you have to, since there's 2 negative signs, that would be a positive sign.
Okay, so we want to make these 2 signs into one sign, and they're the same signs, and same signs become a positive. So we have a positive 4, so now here's what we got, 9 plus 4. Is everybody with us up to that step? Okay, did anybody get caught? Okay, do you see why? And we're not going to make that mistake again, right? Okay. Okay, and then your final answer.
And then it becomes +13.
Very good. Okay. Any questions about that problem? Common mistake. I see that so many times with students. Yes? Because you have a minus -4, and a negative is really just a plus 4. Okay, so when you have, if it was a plus, same signs, that's a plus. A minus, same signs as a plus. If it had been a minus positive, that's different signs, so just been -4. Or a plus minus is just a -4. So different signs become negative, same signs become positive. So that's the same rule for multiplying and dividing. What's your result going to be if you multiply? If you multiply the same signs as positive, if you multiply different signs as negative. Same with division. Okay, who's got the next one? Justin, go ahead. Yep.
And you multiply 96 by -4.
Mm-hmm.
Since it's 2 negatives, you get a positive.
Right, so a negative times a negative, they're the same signs, you get a positive. And what was the magnitude?
And, well, the answer is 20. This answer is 24 since 2 negatives, you get a positive.
Very good, positive 24. Okay, and who's got the last problem for me? Somebody I haven't heard from yet. Amari. Right.
And then to choose a negative, I divide it by a positive.
Right.
Each with the negative sign.
Mm-hmm.
And 4 divided by 2
Okay. So you got a -2. Can I show you guys? So he just saw that we have an improper negative fraction. So the numerator is a larger magnitude than the denominator. So a 4 divided by 2 is going to be 2. And then because they're different signs, it's going to be -2. So that's correct. But I wanted to show you guys another way to think about this that kind of aligns with what we did before. So I can think about -4 as the factor of 2 times -2. Do you guys see that? And then what happens when I cancel out those 2 2's? They become what? They become 1's, right? And so then I have 1 times a -2, so my numerator is -2, and then in the bottom that's just a 1. -2 divided by a positive 1 is just going to be a -2. Any questions about that? All right, so moving along. All right, since I'm making a video with this lesson, if you don't mind, I'm going to go and read this. What you'll learn: to write and evaluate expressions with 2 operations and to solve 2-step equations using number sense. Why learn this? Suppose you are ordering roses online. Roses cost $5 each and shipping costs $10. Your total shipping depends on how many roses you buy. 2-step equations can help you solve everyday problems. You can write expressions with variables using 1 operation. Now you will write algebraic expressions with 2 operations. So we did algebraic expressions with one operations. Those were one-step expressions and one-step equations. Now we're going to have two operations, so we're going to be dealing with two-step equations and two-step expressions, algebraic expressions. Okay, so writing and evaluating expressions. So in the warm-up, we evaluated those expressions for x equals -4, right? Well, anytime you evaluate expression, they give you a number to replace your variable with. You're basically substituting and then simplifying. So these aren't really equations. We're not solving equations. We're just substituting and then simplifying, and that's evaluating. Okay? We're going to be solving equations here within this lesson also. Define a variable and write an algebraic expression for the phrase 10 plus 5 times the number of roses ordered. So I'm just going to walk you through this. I'm going to let n equal the number of roses ordered. Did I have to choose n?
No.
I might have even chosen r, because r might have made sense because we're dealing with roses, right? So whatever variable makes sense to you. Now if I let n equal the number of roses, how would I write my algebraic expression with this variable n? Anybody? Rayhan, sorry, Rayhan.
So you would have 10 plus 5, and then you would also add another you'd also have to multiply, I believe, again
Okay, what am I going to multiply by?
by n.
Okay, so tell me the expression. How would you write the expression? Tell me the start to the finish, writing the expression out.
So it would be 10 plus 5 times n.
Right, so 10 plus 5 times n. But in algebra, typically we don't put that dot there, okay? And you guys recognize I could have wrote n times 5, right? Okay, but in algebra, again, we like to put the number in front as the coefficient. And then we don't like to have this dot because we get rid of it and then the multiplication's implied. So whenever you see this, this means I have a number times the variable. Do you guys understand? Okay. So for algebra, make sure you put your numbers in front all the time. All right. Now, if I say evaluate the expression for 12 roses, can you guys really quickly evaluate that? That's just a really quick number of exercises. Okay. Who's got the answer? What's the answer? Right, it's 70. So let's walk through this. So whenever we work this out, I want you guys to be methodical. And it's not even about, I know that many of you can solve these pretty easily in your head, but you're not always going to be working with really easy equations. Okay, so I want to get you guys in the habit of being like good at documenting your steps. So here it is. I have my equation. I'm going to evaluate it, so I'm going to replace my n with 12. Okay, and so from here to here, it's clear what I did, right? From this step to this step, I replaced the n. And then from here to here, it's clear what I did. What did I do? I multiplied. Okay, and now from here to here, it's clear what my next step is. I did what? I added. So do you see how each of my steps are well documented? Now there's some times where you're going to say, well, I know what's going on here. I'm going to do this one step mentally, but you don't want to skip too many steps when you're showing your work so that you can go back and figure out what's going on. All right, so now what I want you to do is I have this problem. I want you to answer this. I want you to create an algebraic expression for this word phrase, and then I want you to evaluate your algebraic expression for 13. So I'll read it to you. Define a variable and write an algebraic expression for a man. A man is 2 years younger than 3 times his son's age. Okay. Then you're going to evaluate that expression to find the man's age if the son is 13. going to give you a couple hints. I'm going to underline some things. Does anybody have an expression for me? Zach, can you take a guess?
The expression.
Mm-hmm.
So 3a
3a
over 2.
over 2. So you're dividing 3a by 2? No, we're not dividing. There's nothing in there that says to divide. So 3a minus 2. Nice. Okay. So instead of a, I'm going to use s for the son's age. So that's correct. So you have 3, and then the son's age, and minus 2. Do you see where everything came from in the expression? From the word phrase? So 2 years younger, minus 2, and then 3 times the son's age. Okay? All right, so very good. Thank you, Zach. So Zach, can you tell me, once you had that expression, did you evaluate it? Okay, let's go and evaluate it. So here's my expression. I'm going to replace it with 13, the s. And Zach, you could probably mentally do this. What's it going to be? What's this part going to be? $39. So here we are, 39. And now we got one more step. Let's go and do the last step. Mm-hmm. Okay. So the man's 37. Any questions? Did the color coding of the word phrase help you guys understand it at all? What's your question? Oh, it helped? Okay. So any questions about this problem? Are we good? All right, so let's move on. All right, so here's the situation. We're coming up on the holidays. You guys get presents around the holidays? Yeah, do you guys get presents? Okay, for me, I had a younger brother, and I was in high school, and he was in middle school, and he loved video games. And I remember every Christmas, that was usually what he got for Christmas. So this kind of reminded me of that. So using number sense, suppose your grandmother sends you 5 games for your birthday. Each game has the same weight. The box she mails them in weighs 8 ounces. The total weight is 48 ounces. What is the weight of one game? So here's the situation. You see the picture here. There's the 5 games in the box. The box is 8 ounces, and then these 5 games all weigh together 48 ounces. So do you guys understand what's going on? Okay. You can represent this situation in the diagram below. We're going to let G represent the weight of each game. Each game weighs the same thing. Okay, and nowadays a game is just a disc, and you throw it, it has a case, and maybe there's some literature in there, but they're about the same weight. So here we have our total weight. That's this rectangle. And equal to that area is this rectangle down here. We have 5 games, okay, and then we have the weight of the box. So all together, this area is going to equal this area up here. Does that make sense? So my 5 games, but then we see that my 5 games, G plus G plus G plus G plus G, that's really just 5G. Do you guys see that? And then the weight of the box, though they tell us it's 8 grams, or 8 ounces, excuse me. And then all this together is going to be 48 ounces. So here's my equation down here. So you can solve this problem using the equation 5G plus 8 equals the total, which is 48. Since there is more than one operation in the equation, there will be more than one step in the solution. Now, we're going to solve this. And this is where I'm trying to get you guys to think about solving equations as a strategy. Because if we learn the strategy, then we can solve equations that are 3, 4, 5, 6, 7 steps. It's not. It's just using the strategies. So here's what I want you to do. This is the same equation. whenever we solve an equation, we're basically doing reverse PEMDAS. What would reverse PEMDAS be? What would be the first thing to look for in reverse PEMDAS? Go ahead. Add or subtract. Okay, so in this equation, do we have add or subtract on the side of my variable? So this is the side of my variable. Do I have add or subtract? I do. I have add what? 8. So how do I undo add 8? Okay, and then the subtraction property of equality says what? We have to subtract the same thing from both sides for the equation to remain true. So I do that. Now, what's plus 8 minus 8 going to become? 0. And then nothing happens to 5g, but 48 minus 8, what's that going to become? Okay, so now we know 5g plus 0. What's anything plus 0? Itself. So 5g plus 0 is not 99. 5g plus 0 is going to be what? 5g. It doesn't change anything, so 5g. Now, what do I do to get rid of that 5 in front of the g? What's happening between 5 and g? Multiplication. So how do we undo multiply by 5? Divide by 5. So we use the division property of equality that says we got to do division to both sides of the same thing. So we're going to divide both sides by 5. What's 5 divided by 5? 1. And 40 divided by 5 is what? 8. So you see why we got 1g now? And then what's 1 times g? G. That's my answer. Now, what you should do is, for equations, it's a good practice to go back and check your work. So if I go back to the original equation and substitute my answer, 8, I'm going to see if it gives me a true statement back. And it does, so my answer is correct. So here's what I want you to do. I want you to solve these equations, working backwards of PEMDAS to solve these and using inverse operations. Yep. So you look for add or subtract first, then undo those. Then you look for any multiplication, division, and you undo those.
Can I please go somewhere else? Take a pass. Stop this by now.
Can somebody walk us through this first problem? Jose, can you walk me through this first problem? Right, we're going to subtract 9. Very good. And we got to do that to both sides. So what do we get back when we subtract 9 from both sides? Right, so this becomes 0. And then what's this line going to be here? Okay, 0, and that's going to be 12. But we also have the 3m that we didn't do anything with, so we got to bring that down. So 3m plus 0 is 3m. Now we're going to divide both sides by what? Right. And then what do we get back? You get 1m equals 4 or m equals 4. Very good. Okay. Now, who can do this next one? Somebody, now that you've seen a couple of these worked out. Leah? Walk through it. Reverse PEMDAS. We got to find addition or subtraction. Do you see addition or subtraction?
Yes.
Okay, what do we see?
We're going to subtract 5.
Right, we see add 5, so we need to undo add 5 and subtract 5. We got to do subtraction property of equality, so we got to do that to both sides. And then what do we get back?
You get 0 and 40.
Right, so AD plus 0 equals 40. And then that's just going to be AD. And then what?
And then divided by
5. There's no 5 here. Where's 5?
Divided by 8.
Divide by 8, very good. And then what do we get back? D equals what? That equals 5. Because 40 divided by 8 is 5. And then 1 times D is just D. Who's got the last one? Because this threw some people off throughout the day. Let's see if you guys can get this one. Zainab, I haven't heard from you. What's the first thing I got to look for? Do we have add or subtract?
Yeah.
Okay.
So I added
Nice. You caught it. A lot of kids wanted to say subtract, but they were wrong. You added what? 11. So a lot of students throughout the day want to say minus 11 again. But that's not the opposite of minus 11. The opposite of minus 11 is plus 11. So opposite of plus 5, minus 5. Opposite of plus 9, minus 9. So we have to do opposites. Very good. So what do I get when we add 11 to both sides?
33 plus 11 is 45.
Right. And then this becomes 0, so we get 4y plus 0 equals 44. 4y equals 44. You have a question, Ben?
Can I go to the graph?
Yeah, go ahead. Okay, now what's the last step?
And then I divided 44 into 4 to both sides.
We have to divide 4 from both sides, right? And then what do we get back? 11. Very good. And again, does anybody have any questions over these problems? And like I said earlier, it's always good practice to go ahead and check your answer. You're just going to substitute for your answer the variable to confirm that it's correct. Same with your y equals 11. You substitute y for 11, and you confirm that it's correct. Okay. Now, moving on, we're going to get some word problems again. So take a look at this word problem here. Suppose you buy a jumbo lemonade for $1.50 and divide the cost of an order of chicken wings with your friends. Your share of the total bill is $5.50. Write and solve an equation to find the cost of the chicken wings. So here's what's happening. You went out with some friends, 2 of your friends, and your friends are cheapskates. They didn't want to order a drink because drinks to them are expensive, so they just got water because water was free. But you wanted lemonade because you love Chick-fil-A lemonade. And you even told the person at Chick-fil-A that I don't want any ice in my lemonade because you're just going to give me 2 sips of lemonade. I just want lemonade, no ice. So you get lemonade, no ice, and you get a bucket of chicken wings. Okay, so you're going to split these chicken wings, the cost of the chicken wings, with your 2 friends. So in order to do that, you divide by 3, and you're going to pay 1/3 of the cost of the chicken wings. Does that make sense? Okay, so here it is. The lemonade cost $1.50. Your share of the chicken wings was 1/3. So if you take however many the chicken wings cost, for let's say a bucket of chicken wings, and you divide by 3, that's how much you paid for your portion. Okay, so altogether, your lemonade plus your part of the chicken wings equals $5.50. So we're going to figure out how much the chicken wings cost. So the cost of the lemonade plus the cost of the chicken wings divided by 3, that's what I paid for. And that ended up being $5.50. So let z equal the cost of the chicken wings. Here's my equation, but we're not going to write it like that. We're going to write it like this. See if you can solve this equation using the same thinking, reverse PEMDAS, and inverse operations. Can somebody tell me what the first step's going to be? Lopez, what's the first step? Nice. So some students got hung up on this problem until I did this. Remember, if you don't have a sign in front of something, it's plus, right? And so you subtract. You subtracted. What did you subtract? So you subtract from both sides $1.50, right? Okay, when we subtract $1.50 from both sides, what does my equation become?
0 plus 0 over 3 equals $4.
Nice. So here we are. 0 plus 0 over 3 equals $4. Okay, and then what's 0 plus 0 over 3? Or z over 3? It's just going to be z over 3. So this is what we have. That's my equation, right? Okay, now I have z over 3 equals $4, right? How do I get rid of that over 3 or divide by 3? Right? I'm going to multiply by 3, but am I done? No. What do I have to do? It says multiplication property of equality. I have to treat both sides equal, right? So I can't just multiply one side by 3. I got to multiply this side by 3. But in order to multiply this side by 3, this is a fraction. So how do I write times 3 where my 3 is a fraction? How do I rewrite 3 as a fraction? Do you remember? Go ahead. Right. So do you guys see how I got this step right here? 3 over 1 times z over 3. Do you guys understand that? And then we know that we can cross-cancel. And by cross-canceling, this becomes a 1 and this becomes a 1. So what does that side simplify to? Not 1z. It simplifies to z over 1. Or you could say 1z over 1. That works. And then 4 times 3 is 12. And then the last step, what's z divided by 1? Just going to be z. So the bucket of chicken wings costs $12. Any questions? All right. Here's what I want you guys to do. Next problem. So, during the first half of a game, you scored 8 points. In the second half of this basketball game, you scored only 3-point baskets. You finished the game with 23 points. Write and solve an equation to find how many 3-point baskets you made. So let me say what happened. So you're playing basketball. In the first half, you scored 8 points. And in the second half, you don't remember how many points you scored, but you remember that all you did was shoot 3-pointers and you made these 3-pointers. Okay, and then somebody came up to you and said, hey, you scored 23 points during that game. So now you want to go back and figure out how many 3-pointers did I make if I scored 23 points. So here it is. The total points scored, the points scored in the first half, points scored in the second half. So you have 8 points in the first half plus 3 times B. B represents each 3-point basket. Do you guys understand? Okay, so 8 plus 3B equals 23 points total. So points scored in the first half plus 3 points scored in the second half equals 23 points total. So here's what we have for my equation. 8 plus 3B equals 23. Okay. So that's an easy one. Now that you guys saw the last one, this one's an easy one. Go ahead and solve it. Dominique, what's the first thing I need to do? Okay, is there add or subtraction going on? Okay, so what am I going to do in my first step? And what am I going to subtract? Right, very good. We're going to subtract 8 from both sides. And then what do we get back when we subtract 8 from both sides? Uh-huh. Yes, so positive 8 minus 8 is 0, and 23 minus 8 is 15. So we have 0 plus 3b equals 15. So that means 3b equals 15. So what's the last step? Okay, since we have a multiplication between 3 and b, to undo that, we're going to divide by 3. Very good. And we're going to do that to both sides. And what do we get back? Very good. And then 3 divided by 3 is 1. So b equals 5. The number of 3-point baskets scored in the second half is 5. Yes? Yes. Okay, any questions about that problem? And we're going to come to a close. All right, what is the difference between a one-step expression and a two-step expression? Can somebody explain to me the difference? Yes, Mr. Lopez. That's true. There's one step in a one-step equation and 2 steps in a 2-step equation. But you know what? I've been getting that answer all day long. But who can give me a better answer than that? India?
I think you have to divide in a 2-step.
It does have something to do with operations. That's closer, maybe. Ben, go ahead.
In a one-step equation, there's only one operation that you have to perform, but in the two-step, there's 2 operations.
Nice. Did you guys hear that? In a one-step equation, there's only one operation. In a two-step equation, there's two operations. Are we good? Okay, now I feel like we've gone over enough of these models that you guys can tell me what this model represents as an equation. Can somebody tell me that? Raise your hand if you think it. Teray, go ahead.
4x plus negative 12 equals 16.
Nice. 4x plus negative 12 equals 16, but a plus negative 12 simplifies to just a negative 12 because a plus and a negative different signs become a minus. Okay, can you guys solve that really quickly? This is super easy. This will probably take you maybe 30 seconds if you're taking your time. And who would like to share their answer with the class? Go ahead, McKinley.
Alright, so first you want to do is, since it's negative 12,
Right.
you're
We're going to add 12 to undo the minus 12. Very good. So what do we get back?
4x minus 0 equals 16.
Nice. And I put plus, but minus is correct too, because if you minus 0, this doesn't change the thing. If you add 0, it doesn't change. So you're correct still. So keep going.
Alright, now you're going to do, you change the equation to 4x equals 28.
Uh-huh.
You want to divide
Nice.
on each side
By what?
by 4.
Very good. Okay. And what's that going to become?
1x equals 7.
Nice. And then x equals 7. Nice. Very good. Okay. This last part. We need to match these. Well, second to last part. We need to match these word phrases with the expression. Okay. So the first one. Who knows? Who can explain what they think the first one is? Justin, can you tell me what expression matches 10 centimeters less than twice x, your hand length?
Well, that sentence matches with the equation 2x minus 10 because you're subtracting 10 less than
Right. So 10 centimeters less. And you're saying the second one, less. And then twice x is 2x. So I agree with you. That is going to be the second one. Okay, and then who's got the second phrase? Who can walk me through the second phrase? Bokar, you got this one? Let me read it since I'm doing the video. 10 fewer than half x the town's population. Which expression do you think that matches? Nice. So you have 10 fewer, so it's going to be minus 10 again. And then you got half x, right? So you have half x. Now, they could have rewrote this expression another way. How could they have rewritten this expression another way? Anybody have an idea? Couldn't I have written it this way? X 2 minus 10. Isn't that the same expression? Okay. And then last one is kind of given, 10 more. So here you have 10 more plus 10, then 2 times a number x. Okay. It's in there somewhere. Okay, maybe not. All right. So they skipped a line in solving these. But you need to figure out, even though they skipped a line, what is that going to be in the blank spot?
12.
Okay, and how did you get 12? Because in order to get rid of that 5 to just leave us with 4b, I have to subtract 5. So if I subtract 5 from here, I subtract 5 from the right-hand side. 17 minus 5 is going to be 12. Do you guys understand? Okay. And do you guys see why I'm trying to get you to show every step? Eventually, you're going to get really good at these. You're not going to need to show every step. But you can see what happens when you're missing a step, like how it's like, okay, what did I do to get here? Okay, so for this next one, how did I get rid of minus 20 just to have 7c? I got to add 20 to both sides. So that means I already added 20 to this side, and it was left me with 7c. What did I have to add to, and what am I left over here? What goes here, though? 70. Okay. And that is it